Hi girls, on Friday we finished off doing manipulating the figures, the 3D figures or the 2D figures when we had the area and we were working backwards. We also looked at splitting up shapes and getting the area of those. Continuing on from that, today we're going to, first of all, I'm going to just ask you to write down question 19 and 21. These are two questions that we're going to work on in class. What they are is you need to get the area of this odd shape and you need to get the area of this odd shape. The best thing to do is, as you can see, you can split up the shape. There are kind of 4 fingers that are the exact same size. If you get the area of one of these and add it 4 times or multiply it by 4, you get the area of all of that. And then for the bottom piece or slot, it's just going to be 49 by 10. So there are kind of 5 different individual areas on this that you're going to add together to get the total area. The same goes for this. There are kind of 1, 2, 3, 4 areas that are the exact same. So you'll get the area of one of them and you multiply it by 4. And then in the center, it's going to be an 8 by 8 box that you're going to add or multiply to get the area and then add that in as well. For question 21, these are a little bit odd shapes. So imagine you have a box and you cut a hole in the box and all you want is the area going around the outside. You'll get the area of the big shape, that's the 30 by 18. Get the area of the small shape, that's the 24 by 12. And because this is taken out, with the 2 numbers, you will take away. You'll do the same for part 2. So that's how difficult the area questions go. There's nothing too difficult with them. What I'm going to start on is kind of regular solids. These are 3D shapes. So a rectangular solid like this one is known as a cuboid. And we'll be starting to get the spaces occupied by it, which is called the volume. Now, the volume of a rectangular shape is just the length by the width, which is area, by the third dimension, which is height. So this is 2D, and when you multiply it by a third thing, that's the third dimension. Okay, the solid on the right hand side is a cube, and its length and width and height are all the same. So 1 by 1 by 1. 1 by 1 by 1 is 1 centimeter cubed. With this box underneath, it's 6 by 4 by 3. 6 by 4 by 3 is 72 centimeters cubed, and that's how volume works. But what I'd love to get you started on, and I'm just going to write that down first of all. So just in your copy. Okay, this is where we finished on the other day. Your title for this, first of all, can be volume and surface area. So, and today is Monday, the 18th. Okay, Monday the 18th. So I'm just going to draw a cube. It doesn't make a difference if you don't know how to draw a cube, but just do your best. Okay, so there we have a cube. And there's a cuboid. Okay, a cube has all the same edges. So I'm going to say 2, 2, and 2. I'm going to say 6, 4, and 3. I'm going to look at the volume of this. The volume formula never changes. It's the length by the width by the height. To abbreviate volume, you can just do V is equal to length by width by height. So for the first object, it's going to be 2, so 1 volume, so the volume of the first thing is 2 by 2 by 2, which is 8, and I'm going to give a unit, which is centimeters. And because there's 3 things, it's cubed. Okay, so the volume of the first object is 8 centimeters cubed. For the second object, the volume is going to be the length by the width by the height, which in this case is 6 by 4 by 3, which is 72 centimeters cubed. And you can, if you're stuck, you can do all of this on your calculator. You don't need to know how to do it all in your head. You'll just do 6 by 4 by 3. Very straightforward. Okay, that's it. Okay, so volume is a very easy thing to do. Okay, you're just working, this is a 3-dimensional object, so you're a cube like this. Okay, a 3-dimensional object. And this is also three-dimensional, only that it's a rectangular surface as opposed to a square. The tricky thing I'm going to get into now is surface area. And what surface area is, it's the area of each of the surfaces on any of those shapes. So your title is surface area. And it's the area on all surfaces of a 3D object. So for me, I'm going to talk about the cube. The cube has 6 faces, okay? And I'll just demonstrate for a second by opening it all up. Okay, there's 6 of them. 1, 2, 3, 4, 5, 6. The bottom, the front and the back, the 2 sides, and then the top that goes on top. And for a square, all of them are the exact same size. But there's a bottom and a top that will have to be the exact same size. If this was a rectangle, a cuboid, the bottom and top would have to be the same size. The front and back would have to be the same size because they match up, and the 2 sides would have to be the same size. But just for a cube, to get this surface area, you have 6 sides that are the exact same. And if you want to get the area of one of these sides, it's the length by the width that we've seen before. So it's just 6 times the length by the width. So for us, that's the length by width is 2 by 2. From this 2 by 2. And that's 4 by 6 is 24 centimeters. And its area squared. Okay. For a cuboid, it's slightly different. As I was trying to explain there earlier on, the front and the back are the exact same measurements. The bottom and the top will be the exact same measurements. And the 2 sides, because they're opposite each other, will be the exact same measurements. So I'm just going to demonstrate from this. This is the front. And that's the back. They're the exact same size. So there's 2 of them. And that's going to be the length by the height, which is a 6 by 3, because they're the same. Plus, this is a side, and at the back here is another side. Okay, and they're the exact same. So it's 2 times the width by the height, because the width of it is 4 and the height of it is 3. And finally, the bottom here, so I'm just going to do a different color. So the bottom and the top are the exact same size, and that's still going to be the 6 by the 4, which is a length by a width. So for any 3D shape, well, for most 3D shapes, or whether it's a cube or a cuboid, there's 6 different sides. So 6, 2, 4, 6, that's 6 as well. And that's how you calculate it. And I'm just going to start the calculation here. The length of this is 6 and the height of it is 3. The width of this is 4 and the height of it is 3. And finally, 2 times the length of this is 6 and the width of it is 4. And you take each little math sum separately. So 2, 6 by 3 is 18. 4 by 3 is 12. 6 by 4 is 24. Okay, and then you multiply by 2 by 18 is 36. Plus 24 plus 48. You can grab your calculator then. So 36 plus 24 plus 48. That's 108 centimeters squared. The reason that you do a thing called surface area is, imagine that was a box, a present, and you wanted to wrap the present all the way around, so you cover this surface and that surface and this one and all 6 surfaces, and you needed to figure out how much paper did you need. What was the area of the paper that you need? Well, the area of the paper that you need needs to be 108 centimeters squared. And if you have 108 centimeters squared, you will perfectly wrap that present. Okay, so that's what that is. Okay, so surface area, we've looked at surface area and we've looked at volume. So volume is getting the space inside the 3D object. So that's the length by the width by the height. And surface area is getting the area of each of the surfaces on the object. So now that we have that, that's the teaching bit of it done. Okay, so surface area is 2 times the length by the width, 2 times the length by the height, 2 times the width by the height. The volume is, for a cube, is length by length by length, which is length cubed, or the surface area is length the area 6 times, like I shown you there a couple of minutes ago. For classwork, we're going to do question 1, question 2, and question 3. So I'll just write down all of the classwork now. So today we are going to look at, on page 205, question 19 and 21. And then we're going to go to page 208. And we're going to do questions 1, 2, and 3. Okay, and that's where we're leaving it. So you can start those now, and I'm going to join you live in the next couple of minutes. Thank you.